Hello guys, this is Adam and what you are looking at is the MacBook Neo, the base model with 256GB of storage and 8GB of RAM. The reason I have activity monitor right here is just because I want to talk about memory consumption for the MacBook Neo and then in relation to Blender as well. So here I have the Party Tug project, and the reason I chose the Party Tug project, aside from every memory consumption project that I ever did, or a video for that matter, I always use this so we can have consistent results when you compare it to the M5, to the M2, M3, 4, because all of these are on the channel. You can go ahead and check them. Aside from that, it's one of the more demanding projects, so to speak, so we can at least get an idea for the consumption and how it's being optimized for the MacBook Neo as well. And then here the memory used in total is 6. Swap memory is at 0, which is surprising, so we're not using any swap memory. And if you do not know what swap memory is, basically your machine, it has an SSD storage that is inside it. Your device has a physical memory, so your physical memory is 8. Sometimes your machine, you open a lot of stuff all at the same time, and your laptop needs more than 8. When it needs more than 8, it will use this, which is called the swap memory, or swap used in this case. That's the description for it here. And a swap is taking out of your hard drive, the physical hard drive, the SSD that is inside the machine, taking a space out of it to act as physical memory. So let's say we need 10 gigabyte of physical memory and we only have 8, then a swap would give us 2 gigabytes. So these two will be added plus these 8, so we can have 10. And as long as you have a free space in your laptop, you can actually get a swap memory. That's why I do recommend, if you are getting the MacBook Neo, either get an external hard drive so you can have some free space here on your machine for it to be used for a swap memory, or get the 512 gigabyte version. Which, speaking of which, I do actually have hard drives connected, and I am connecting them through this docking station right here, which if you want to know more about this wavelength docking station, there is a bunch of videos here on the channel for it. You can go ahead and check them out. I might leave a link for you below the subscribe button, and while you're there, click it please. It would help me greatly. So this is basically what a swap memory means. Now we're gonna go back to Blender. Let's go ahead and go to edit and then to preferences, and then from preferences here we are using the GPU instead of using the CPU. Keep in mind, if you want your render to be fast, use only the GPU. If the GPU is not enough and it's telling you, hey, there is not enough memory while you are rendering on the MacBook Neo, because that does happen, and we have seen that while testing the machine in a general sense, and there are videos here about it on the channel as well, then in this case use both the GPU and the CPU at the same time. However, never use the CPU only, because if you use the CPU only, in this case the Apple A18 Pro chip, it's actually going to be slower. Let's go ahead and do a quick render, and while this is rendering, we will see how long it takes. Granted, I do not care how much this would take. As much what I care about is the memory intake and the memory consumption, and how does the memory works while we are rendering. So I'm gonna go ahead and open it, and as you can see right here, we actually went to the yellow, and yellow means basically we had some pressure while we are doing something on the Mac. So basically we used more than the RAM that is available with the machine, and this tick was probably the initial tick when I did a click hit render. The render is done, and it took only 24 seconds, and again, that's using Eevee and using the GPU. That's why using the GPU is good, and it will not take a very long time. Let's go ahead and change that, and then do cycles, and then with the cycles we're gonna do GPU, and then we're gonna go ahead and render using cycles. Now cycles is gonna take more time. We do not care how long this is gonna take, because I just want to look at the memory right here, and as you can see, the memory was red. That means we were putting a lot of pressure on it, and as you can see, your swap memory actually jumped to 2.5. That's almost to 3 gigabytes. A Blender right here is actually using 9 gigabytes, and 9 gigabytes, that's more than what the machine would allow you to use, which is basically, well, not allow you to use, but what it has as a physical memory, and that is 8. And right now we are at 9.8, and we are hitting 10 gigabytes. So that's why, as I explained earlier, swap memory is being used, because we need more than 8 gigabytes. And right now it's going back to the green, and probably it's going back to the green because the whole render is done. But when it was rendering and taking a lot of memory, it was actually started at the red and here at the yellow, and now it's back at the yellow again. Do not be scared. This is not like scary. However, this is telling us that the consumption can be high and there is, only so much that you can do with 8 gigabytes. So you need to swap memory for you to actually do whatever you need to do. Okay, so right now we are at 78%. We are getting this yellow thingy. That means the machine is trying to push through for the last push. And then here, if we go to the memory, holy cow, the memory was struggling. The machine, no, I wouldn't say it's slow, but definitely the machine is struggling, and we are using about 2 gigabytes of swap memory. Now I am trying to go back to Blender. It's taking a second for it to go back to Blender. So I'm gonna wait for it to render completely. And it seems like this project is gonna take about 3 minutes for it to render completely using the GPU compute. So it is done, and it took 3 minutes and 46 seconds. You can definitely compare that against what you have. However, I do not care about the number for that because this is the first run. That means it's the kernel run, so it's not the actual run. If we want the actual run, we need to run it again. That is after the kernel has been built, because right now it's saying using optimized kernels, because when you run it for the very first time, the kernels are not optimized, and usually that is not the number that you should go with if you are trying to know how long this would take as an actual render. But the second time usually is the number that you go with, because now it's using the optimized kernels after it has optimized everything. And usually the way it works, you open a Blender, you render for the first time something, and then it gets the kernel built, and then after that you can get your numbers. So now this second run, if we wanna care about the numbers, actually will give us an actual number. While this is doing its thing and it's rendering, again using GPU compute through cycles, let's go ahead and holy bananas. We started red and right now we are at yellow again. Now we were at the green because the render was done for a bit, but now we're just, sitting at the yellow. So the memory consumption is quite high. Keep in mind, you only have 8 gigabytes of RAM, so there is only so much that you can do. And through my review video for the MacBook Neo, I said the only thing that I will knock it for is the render times and the render ability, because you only have 8 gigabyte, and that 8 gigabyte is not only, let's say, physical memory for your RAM, because it's your GPU and your RAM. So both are combined. A shared SoC, system on a chip, that's what it stands for, or basically they are both combined into one thing. And then when they are combined into one chip, they are fighting to which is gonna use the resource that it needs. So that's why we have this very high consumption. So now I'm actually curious to see how long this would take to render, and then we can probably compare the number against what we had when the kernel was not optimized, because right now the kernel is optimized, and whatever number we are getting, that would be our actual number, and then you can compare that against what you have. And then the way to make sure that your kernel is built, when you render for the first time, it would tell you here that, hey, you are using optimized kernels, and then you can compare it against what we have right here. So we are rendering a frame 37 in case you open the project and it was not on a frame 37. Usually when you open it, it's on a frame 37 anyway. And then it took 2 minutes and 48 seconds. That's after the kernel is run, and that's what we are actually looking at, and the actual number. Now as you can see, it's like whoosh, and now it went to the green again. Blender is only using 5 gigabytes, so it was cut almost by half, and then it's no longer in the yellow. Projects such as the party tug, they do consume a lot of memory, and they do put the machine to its basis. And some other projects, for example the junk shop project, it will actually give you a warning that, hey, there is not enough GPU memory for me to finish that project. So then you need to depend on using your GPU and your CPU to render it. The biggest limitations that this machine has, it has only 8 gigabytes of RAM, but that only affects you not while you are working and sculpting or using Grace Pencil and then you are making something. It will only affect you while you are rendering. Blender actually does a good job with then optimizing the resources. If we are using Arnold through Maya, or we are using Unreal Engine or Unity, it's gonna get ugly and it's gonna get nasty, and it's gonna take a decent amount of time for it to render. But again, we're talking about 3D projects. Now if you're talking about video editing, is not that most intense of a task. Honestly, whoever does video editing tests, like, I do not want to say they do not know what they are talking about, but video editing is not the most intensive, crazy thing that you can do on a machine. This machine can handle video editing just fine. I have done it. Even After Effects, I have done it. It was working just fine. You can check those videos if you want on the channel. But in terms of a 3D, and especially rendering, this machine definitely does struggle, and that's the only struggle that it has. But if you are working or modeling or wherever that may be, that is not an issue. And I made a plethora of videos about that where you can watch me work on real time on something where I didn't have any issues. If you have any comments or concerns, leave them in the comments below. And while you're doing that, hit the subscribe button, and I will see you soon.